The company started in the late 1970s. We were mining at the time, doing some leaching of a complex ore. From there we got into amalgamation, and we were doing fire assaying. We started selling our equipment, supplies, and information through a catalog around the world. We started teaching seminars in the 80s and started our magazine, Popular Mining. From there it just kept growing, and we kept selling more things, and came over to Vegas from California, and things have been going real well since then.
There's three adjustments. We have a water flow. We have how hard the table actually hits, and then we have the tilt of the table. The water flow is to make the ore move. We don't care if it's real clean water as long as it's not so dirty that it's interfering with the flow of your ore. So that just a simple screening operation and a recycling of your water is very good. You will lose some of your water because of wetting of your ore, but most all your water will be recycled and used over again. The adjustment of how the table bumps or how hard it actually hits, which is what pulls the gold to the top of the table for our concentration line, is as little as possible. What we're trying to do is bring it to us, not hit it real hard, because the bump is not to drive the gold. The bump is actually just to move the gold. If you actually drive the table too hard or hit the bump too hard, it actually forces the gold to go in the opposite direction. Is not good. And then the tilt of the table, how high the back of the table or the end that you actually feed the ore, in which you also take off your concentrates, is higher than the discharge end, which is where your tails come out. In production, we're looking at running approximately 1,500 to 2,000 pounds an hour. With that, your table tilt is somewhere between 1 and 2 inches. That's regulated by how much concentrate you want, how heavy they are, this type of things to which you will be testing to find the concentration level you need. The other is when you're just running testing, or you're running high-grade concentrates where you're only running maybe 5 pounds or 5-gallon bucket of material. You will then be running upward between, let's say, 4 and 5 inches, concentrates out of Alaska, black sands cons, 5.5, 6 maybe, black sands out of North America here. Normally we run them between 4 and 5. Magnetics somewhere between 5 and maybe a little higher, just depending on what they are. The way it's set up now is when you actually first get your table, you have an adjustment for your legs are adjustable, your water flow is adjustable, your bump is adjustable, and you would use it as is. When you go to production, there's actually counterweight, so you add weight to the counterweight, which actually makes the table drive harder. They are not to be used until you are in a production operation. If you use them before then, the table really hits way too hard for the amount of weight that's on the table. The tabletop itself is made out of fiberglass. It's a marine resin. We have never had anybody wear it out. We've had people that dropped way too big rocks on it and crack it. But all of those things are easily repaired. You can even take them locally to anybody that actually works with fiberglass. Tell them to get a good marine grade can't think of the coat, blue coating, gel coat, a marine grade gel coat. What they have to do is sand the table down, the inside of it, and spray it very carefully so that they have a nice smooth surface. After they're done, you will wipe it down with acetone, and then you'll take a 200 mesh sanding to it and sand the whole table down, the inside of it down, so it's nice and smooth and rough. You will not want to leave the gel coat on there unsurfaced, because A gel coat is actually got oils in it, and it will skim over, and then you'll have an oil in it that you need a roughness for that gold to move with. The table actually works on linear bearings, which keep the table going up and down, does not allow it to shake and move around in any direction that we do not want, which is one of the reasons that the table has to be bolted to the ground very securely so that it is not moving. The only moving part that you want on your table is actually the tabletop itself going back and forth. Patent pending on the action it is itself is a patent pending operation. Like I said, it's a refinement of some old operations. The patent pending is basically set up for the mechanical driving of it itself. The M7, well, let's start at the M4. M4 is the smaller lab table, runs on 12-volt batteries, or 12-volt electricity DC. Can be run from a car if it had on a trailer. The M7, the patent pending parts are your linear bearings and how it's set up, and the offset weights, the ways it runs. The M10 sets on linear bearings, is run by hydraulics, so that you have a very fine tuning that you can do with the M10. The M10 is actually is made for primary concentration. When you're running 5 to 8 tons an hour, testing 100 pounds on the M10 will not really work at all because it's not set up to even set up to be able to do that. Now, the M7, M10, when we're making a concentration, it's normally more cons than under normal circumstances that most people are looking at. We're looking for maybe a 10-to-1 cut on a first pass of an ore. That means that if you run 2,000 pounds, you have 200 pounds of concentrate. Now that sounds like an awful lot of concentrates, but it doesn't mean much to us because the table will run 200 pounds in about a half an hour and you've got all your gold out of it. What your primary concentrate is to knock down the bulk of your material and make sure that you have all of your gold in a concentrate. We consider a 70% to 75% is a good commercial recovery system. We are normally looking for somewhere between 85 and 90% recovery on our commercial operations. But to do that, like I said, we're running a lot more concentrates and then rerunning them on the M7 table. Like I said, that once set up in a line, it makes it real easy. You'll not even notice your concentration levels because of its flow through. The M7, or actually all of the tables, they're primarily made for microscopic gold. That's what we got started with in the business. And we're talking about gold that's 120 mesh and finer. We have commercial operations that are separating at 5 microns. It's a special operation. They're actually collecting silica carbide crystals at 5 microns. They get about a 98% purity at 5 micron. Any finer than that, they start getting too much. They have to have the 98% purity. Most tables are not actually, there are any of your gravity feed mechanisms that are out there, they will collect a small percentage of that, but the problem that they have is that you cannot separate that fineness from the bulk of the concentrate. With us, we can actually separate that fine microscopic gold out of anything that comes along to a point to where we can make a commercially valuable product. We don't only just do the gold. We also, like I said, we have companies getting silica carbide crystals, tungsten with scheelite, zinc oxides, and we have a plastic manufacturer that actually is collecting what their product is the plastic, and what they're trying to do is get all of the sanding media that they use to grind up to actually sand off the paints and the plastics off of airplanes. They're trying to separate that from the plastics. They need the plastics. They want to get rid of the grinding media. In that case, in gold, our specific gravities are going to the top of the table, and our tails are going to the bottom. In a case like that they're plastics and trying to separate the heavy sand media out of it. Their product is actually in our case, would look like the tails. In other words, they're going out the bottom end, and all the trash is going out the top end. But primarily, we got started, like I said, we got started on the microscopic gold, or the gold that was 120 mesh and finer, to get to a concentrate that you could smelt and make a concentrate out of. 10% by weight is normally a sellable product. In other words, if you have a pound of material and you have about an ounce and a half of gold in that, this is a sellable product. You can then take that and either smelt it, make a dory bar out of it, or there's refiners that will buy it at that stage. And with our tables, we can do that. We can take that fine gold, separate it from the bulk of their concentrates, and make it a sellable product. And do it quickly and easily. There's been a couple of improvements over the years on our table. The basic mechanism of it is stayed the same, the linear bearings and the shafts and the weights, the bigger tables under the hydraulics. But we've added we call it a hydraulic riffle bar. You'll see that in the demonstration of the table running, which forces the slurry to run faster through the table. Now, the other thing that we've added, and it's on the big table, the M10, and you do get it with the M7, is a matting with V grooves in it. Now, the V actually goes the length of the table, and what it's for is, in the small, the M7, primarily is for like plaster operations where you're actually screening and not grinding. What that does is it lets the ultrafine product that you're trying to collect get down in the bottom of the V so that you can run bigger material without fear of losing the fineness, because what it does is the V lets the fine material get down into the groove, and the larger stuff stays at the top of the V so that you can run larger material with your finer gold. And on a big table, it is put on the table. It's set there. It's put in there so that in a production operation, there's always bigger material that gets through your screen. It's just one of those Murphy's laws, and how it does that, we do not know. But that keeps that from having a problem. In other words, if a quarter-inch rock gets on through your material to the table, that quarter-inch rock is not going to affect the recovery of your fine gold, because it cannot get to it. It cannot get to it and hit it, because when you're talking microscopic gold, you start talking down to 200 mesh, 300 mesh gold, 5 micron. If you're looking at a piece of sand and you can actually see that piece of sand and feel it in your fingers, and you throw it on a table and you get it mixed in with the fine gold, that piece of sand is heavier physically than that 5 micron, 10 micron, 100 micron piece of gold. It will move the gold, and that's not what we want. So what we have is that grooves, and that makes that takes care of that problem, and makes it more forgiving for the customers that are actually running the tables. Leaching table. It is a very cost-efficient and technically one of the least technical type pieces of equipment In other words, you don't need to be very technically inclined to be able to run it. Once it's up and running, once everything is running, you can leave it alone. You can leave it as long as everything, all the rest of your equipment is running, leave it alone and it'll run by itself. The other options you have are leaching, flotation cells, amalgamation. Now, we sell and have proprietary formulas for leaching. We have amalgamation equipment and have proprietary formulas for amalgamation. For technically involved, or how technical you need to be, the top of the line is leaching. It's a very technical, intensive type of operation. You cannot leave it at any time. You have to stay right on top of it. If things change in a leaching operation, it is very possible to lose everything that you've been doing up until that point. Very expensive. Leaching is your most expensive operation that you can do in a mining operation. The next one down from that is amalgamation. Amalgamation is got this mystique about it in that all you have to do is add your mercury and your gold, it gets together, and then you've got your gold. It is not under any circumstances that easy unless you are one of the 1% out of the hundreds of operations that are out there. Amalgamation, three basic things have to happen. Your mercury has to be clean, your gold has to be clean, and they have to come in contact. And those are the three basic things that have to happen in amalgamation. Not easy to do. Under most circumstances, your mercury gets dirty very quickly. 50% of the time, your gold is dirty to start with, has organic oils, will not amalgamate. And it is the next technically intensive operation. Just because now, if everything worked right and you've got your gold and your mercury, you're not done. You now have a complete new operation to get your gold back out of your mercury and clean up your mercury again.